In this video, we're gonna talk about the equation of line in three-dimensional. So if you record the equation of line in two dimension, so you see that you're gonna have the x-axis and the y-axis, and you have the equation of line determined by using the slope y equal to mx plus c. Okay, so this one will be your x and y. Okay, so you have y equal to mx plus c, and this one y equal m here is gonna be the slope. Okay, and you have your c is the intercept. Okay, so the slope equal to m, the intercept is at c. Okay, and the thing that you're gonna have in three dimension is gonna be a little bit different, because it's not turned out to be a slope that used to determine the equation of the line. It's gonna turn out to be, you see that if you have a line in three-dimensional, the thing that you can fix for this line will be you have one point on this line. Okay, P0 is a point on this line, and you're gonna have this line parallel to a vector v. Okay, so this one is gonna be the direction vector. Okay, so it's gonna be direction vector, and you have one point. And you see that if you have the line, or if you construct the vector, so if you have P0P, let me draw P0P. So if you see that your vector A, which is the vector P0P, turn out to be parallel to the direction vector V. Okay, so you have P0P parallel with the vector V. Okay, so it's going to be parallel with the vector V. And this one will be used as the slope. Okay, can think about, okay, as slope. However, in order to have the slope in three-dimensional, it's going to turn out to use a direction vector. So we have P0P parallel with vector V. So I taught you last time that when you have two vector parallel, it's gonna turn out to be that V turn out to be equal to TV. Okay, so this one is multiple of V. Okay, so this one will turn out to be used in order to determine the what is called the equation of the line. The equation of the line will be the relationship that you use to find x, y, and z. Okay, so you see that you have any point on the line P, and you need to know x equal to, okay, so you need x equal to, y equal to, and z equal to in order to get the equation of the line. So we like to know what will be x, y, and z in terms of what? In terms of the point that you have P0 and the vector that you have your line parallel to, so it's going to be V. So the P0P turned out to be x minus x0, y minus y0, and z minus z0. Okay, and the vector TV, okay, so we're gonna let V equal to ABC. Okay, so if you let V equal to ABC, the thing that you get here will be, it's gonna turn out to be TABC. And so you see that you have x minus x0, y minus y0, z minus z0 equal to t, a, b, c. So from this one, you may derive that you have x, y, z minus x0, y0, z0 equal to t, a, b, c. Okay, so you would get x, y, z equal to x0, y0, z0 plus t, a, b, c. Okay, so you see it's turned out that, hey, it's gonna be just, this one is gonna be your point, right? So this one is gonna be your point. Okay, and this one turned out to be your vector. Okay, so you see that you use your point here and you use your vector here. So it's similar to the point slope form. Okay, so it's similar to the point slope form that you have your slope here. Okay, so you have your slope here. This one is going to be your slope, and the parameter is going to be t instead of x. And your relation here is going to be x, y, z equal to x0, y0, z0 plus t, a, b, c. And the letter t here is going to be parameter. The parameter t will be vary according to the position of the point on the line. If it here, t gonna be one value. If it here, it's gonna be another value of t. Okay, and this guy is called vector equation. Okay, I gonna highlight it here. So this one is gonna be called vector equation. Okay, so this one is called vector equation. Okay, so you have the first kinds of equation of line turn out to be called vector equation, and the vector equation you have point, you have vector. Okay, that is gonna be direction vector. Okay, so it's gonna be direction vector. And another thing that you see is going to be, let me erase the highlight a little bit. I'd like you to see another thing. So when you see this one, you see that I use different color. Okay, so let me just give you this thing clearer. So you have X, Y, Z. Okay, so you see that you can compare each component. So you see you have the first component, which is x. X will be equal to x0 plus at. Y will be equal to y0 plus bt. And z will be z0 plus ct. And t is in real number. So you have this equation are called parametric equation of the line L. So this one is called parametric equation, and this guy is called vector equation, and this guy is called parametric equation. Parametric equation. And we have plural here because you have three equations. Okay, so you have three equations, so it's turned out to be plural. Okay, so you see that we have the first one is called vector equation. The second one is called parametric equation. And the way to set up is going to turn out to be just use the point and you use the direction vector. Okay, so you're going to just use the point and the direction vector basically. So let me highlight this one and this one that you use. You use point and you use direction vector. Okay, let me give you one example first. So we like to find an equation of the line that passes through to one, through 4, -1. Okay, so this one will be point. Okay, and parallel to the vector I minus 3k. So vector v in this case turn out to be 1, 0, -3. Okay, so this one will be your point and your direction vector. So you're gonna just write down, hey, it's gonna be simple. X, Y, Z equal to point. So you put point to 4, -1. Okay, plus t, and you have the vector which is 1, 0, -3. Okay, so this one is going to be vector equation. Okay, so it's going to be vector equation. And if I like you to find parametric equation, you're gonna just give me x, y, and z. So it's gonna be x, y, z. Okay, so it's gonna be x equal to 2 plus t, y equal to 4 plus 0t, and z equal to what? Z equal to -1 minus 3t. Okay, so this one will give you the thing that called parametric equation. Okay, so you have x, y, and z. Okay, so let's do one more. Okay, so this one will be just x, y, and z. The thing that I like you to see also will be, you see that if I highlight, this one is going to be the pink one, orange, and the blue one. Okay, so this one is how you obtain the parametric equation. The next one, if you like to find parametric equation and the symmetric equation that we're going to discuss later of the line that passes through the point A 2, 4, -1 and B equal to 3, -2, 1. Okay, so we have 2 points and we have line. Let's draw the line first. And you have 2 point A, which is 2, 4, -1. And another point is B, 3, -2, 1. Okay. So you see that we have point. Okay, so you can pick any point. Let's use B. So this one will be point on the line. And the direction vector, okay, the direction vector V will be the vector that the line parallel. So in this case, we use V equal to vector AB. Okay, so we use V equal to AB. Okay, so we use V equal to AB. So the direction vector gonna be AB equal to, so it's going to be what? 3 minus 2, negative 2 minus 4, 1 minus negative 1. Okay, so it's going to be 1, negative 6, and 2. Okay, so in this case, you're gonna have x, y, z equal to, okay, x0, y0, z0, so it's gonna be 3, negative 2, 1, which gonna be the point, okay, and you're gonna plus t 1, negative 6, 2, okay, so this one will be point, and this one will be direction vector. So you're gonna be able to get the parametric equation. So you're gonna have x equal to 3 plus t, y equal to negative 2 minus 6t, and z equal to 1 plus 2t. Okay, so you have x, y, and z like this. And one thing that can be done turn out to be the thing that I like you to see will be when you use these kinds of equation. So you see the point, where you see the point. So the point is going to be 3, negative 2, 1. And 3, negative 2, 1 turn out to be here. Okay, so it's going to be 3, negative 2, 1. And the vector 1, negative 6, 2 turn out to be the coefficient of 3. Okay, so it's turned out to be the coefficient of t. So it means that you're going to use point as the constant in the parametric equation, and you're going to use the vector. It's going to turn out to be the coefficient of t at each component x, y, and z. Okay. Another thing that we can do is going to be, we can solve for t. So from the first guy, you solve for t, you're going to get x minus 3. The second guy, you get y plus 2 over negative 6. And the third guy, you get z minus 1 over 2. Okay. So you see that you have t equal to x minus 3, t equal to y plus 2 over 6, and z equal to z minus 1. So this guy are solving from the parametric equation. However, they are equal to each other because they are just t. So this guy equal to or, so you're gonna get the equation in terms of x minus 3, y plus 2 over negative 6, and z minus 1 over 2. Okay, and for the sake of completeness, let me over 1 here. So you see that this one, the vector turn out to be on the bottom. Okay, 1 gonna be under x, negative 6 gonna be under y, and 2 gonna be under z. Okay, and you're gonna have the point. Okay, so the point turn out to be here next to x, y, and z. Okay, so you see the place where I'm using point and vector. Okay, so vector, and here you see that it's gonna be the place you are using for point. Okay, and these are the place that you are using for vector. Okay, so that is gonna be another kinds of equation. Okay, so the equation in this form is called symmetric equation. Okay, so this equation is gonna call symmetric equation. Okay, so it's gonna be called symmetric equation. The symmetric equation gonna be the equation that involving no t at all, because we solve for t, and it's gonna involve only the point. The point gonna be used with x next to y, and next to z, and the vector t gonna be under x, under y, and under z respectively. Okay, so that is gonna be how we have the symmetric equation. So let me go back to discuss about the symmetric equation. So we have one way to present the equation of the line. So it's going to be the vector equation, the parametric equation, and you also have another way which is called the symmetric equation. The symmetric equation will use the point x0, y0 next to x, y, and z, and you're going to use the vector under x, under y, and under z respectively. Okay. However, you're gonna have one problem when you like to write down the symmetric equation, which is turn out to be kind of strange if you have the bottom equal to 0. Okay, so I'm gonna pause here a little bit for you to copy this one down. What will happen if you have the vector, the component of the vector turn out to be equal to 0? Okay, so you see that you have no problem solving. Okay, so this one, let me erase this guy a little bit. And I'm gonna say parametric equation. Okay, so you see that if you solve for t, you can have t equal to x minus 2. Okay, and you have t equal to z plus 1 over negative 3. Okay, and you have t equal to y minus 4 over 0. So this one is gonna be wrong, okay? As you can see that it cannot be y minus 4 equal y minus 4 over 0. So this one cannot be done this way. So you're gonna just simply get y equal to 4. Okay, so you're gonna just not be able to have this one, okay? So for here, you see that you're gonna get y equal to 4. Okay, so you're gonna get y equal to 4. And then for x and z, this guy can be right in the way that x minus 2 equal to z plus 1 over negative 3. Okay, and for the sake of completeness, let's over 1. Okay. However, when we have one component equal to 0, you're gonna write this guy next to. So this guy is gonna be, you're gonna just add y equal to 4. Okay. So when you see something like this, it does mean that t, okay, so it's gonna be that the coefficient of t is 0. Okay, so this one is mean that this coefficient turn out to be 0 when you not seeing something under y. Okay, so the way that we're gonna read is gonna be we're gonna read the point. Okay, the point turn out to be 2, -1. Okay, 2, 4, and -1. Okay, that's what we can read from the point. The way to read the vector will be 1, 0, -3. Okay, that is gonna be correct. So let's test you a little bit. When you have the line L1 and L2, can you find point for me? Okay, can you find a point for me? So when you see something like this, okay, what will be the point? The point that you have here is gonna be these 2, -1 and 2. Okay, so the point will be 2, -1 and 2. And the vector, okay, so the vector v will be the coefficient of the parameter. So the coefficient turn out to be 1, 3, -3. Okay, so it's going to be 1, 3, and -3. Okay, so that will be point and vector. Another guy will be the point turn out to be 4, 5, and you see nothing here. So it's going to be 4, 5, and 0. Okay. And the vector v turn out to be 1, 3, and 1. Okay. So the vector v turn out to be 1, 3, and 1. So that will be the point, and it's going to be the vector. Okay. So for the next one, let's read here. So you see it's x minus 1, 2 minus y, and z. So you see that this guy is x minus 1 over 2. Okay, we must put this one in the standard form first. And it's going to be y minus 2 over -1. And it's going to be z minus 0 over 1. Okay, so you can see that after we put in this way, you're going to have point given by 1, 2, 0, and the vector turn out to be 2, -1, 1. Okay. For another one, you see that this guy can be put in terms of x minus 1/2. Okay, so you must move 2 out. So it's going to be x minus 1/2 over 3, y minus 0 over 1, and z minus 2 over 1. Okay, and you see also that these two can be moved down here. Okay, so you would get point which is 1/2, 0, 2, and the vector turn out to be 3/2, 1, 1. Okay, and that will be point and vector that come from the parametric equation, symmetric equation. Okay, so this one will be the thing that you have. Okay, so I hope that you understand when you see the equation of line, you have to be able to determine direction vector and the point. Okay. Let's answer question B. At what point does this line intersect the xy plane? Okay, at what point does this line intersect the xy plane? When you have the xy plane, Okay, when you have the xy plane, it means that you are having z equal to 0. Okay, so when you have the xy plane, it means that you have z equal to 0. So we need to find x, y when z equal to 0. Okay, so the meaning for this question turned out to be you like to find x, y when z equal to 0. So we can use this equation. So you get 0 equal to 1 plus 2t. So this would allow you to solve for t equal to negative 1/2. Okay, so c equal to negative 0.5. And then this will be x equal to 3 plus negative 0.5. So it's going to be 2.5. Okay, and you have y equal to negative 2 minus 6 negative 0.5. So it's going to be negative 2 plus 3 equal to 1. So the point on the xy plane is, okay, so the point on the xy plane is 2.5. Okay, it can be parentheses or it can be angle parentheses. It doesn't matter. Okay, I'm not gonna deduct you for using the wrong parentheses. I'm not quite care. Actually, you can use all parentheses. It's gonna be 1 and 0. Okay, so just have your x, y, and z correctly. Okay, that's gonna be matter. Okay, so that will be the point on the xy plane that this line intersect. Okay, so it mean what? It mean you have this x, y, z, okay, and you're gonna have your line like this. Okay, so it's gonna be at this point, okay, that the line intersect the xy plane. So it's gonna be the point that the line intersect before going under the floor. Okay, so that is gonna be it for question B. Okay, so that will be the introduction for the equation of the line. Okay, so you're gonna be able to determine the equation of the line. You'll be able to find equation of the line in 3 ways. So it's gonna be parametric equation, symmetric equation, and it's gonna be the vector equation. Okay, normally the thing that I will ask you turn out to be parametric equation and what, and symmetric equation. Another thing will be if you have the line in 3-dimensional, the thing that you can see is going to be if you have 2 lines, these 2 lines turn out to be intersect. Okay, so that is going to be the first case. So this guy intersect. Okay, another line can be parallel. Okay, so it can be parallel like this, or the line turn out to be skew line. What does it mean to be skew line? Skew line parallel is gonna be like this. Okay, so you have the line that parallel to each other. However, if you have the skew line, it's gonna be they're not parallel. However, they won't be intersect. Okay, so they not parallel, neither parallel nor intersect. So in that case, it's gonna turn out to be called skewed line. So the skewed line in this case turned out to be the skew line in this case turned out to be not intersect and not parallel. So that's what is mean. Okay, do not intersect and they are not parallel. Okay. So we like to find the intersection point of the line L1 and L2. Okay, so we like to find the intersection point of the line L1 and L2. In this case, it's gonna be, you have, okay, x equal to 2 plus s, okay, y equal to negative 1 plus 3s, and z equal to 2 plus 3s. So you see that the way to solve this kind of equation will be you're gonna let x equal to each other, y equal to each other, and z equal to each other. So this would yield you 2 plus s equal to 4 plus t, negative 1 plus 3s equal to 5 plus 3t, and you have 2 minus 3s equal to t. Okay, so you see that you have three equations and you like to solve for s and t simultaneously. Okay, so this one you like to find the intersection point. So if you be able to solve for this guy, it's gonna turn out to be intersect. However, if you not be able to find s and t that satisfy these three equations simultaneously, it's gonna be not intersect. Okay, so I'm gonna just say that we're gonna solve for s and t simultaneously. Okay, if any. Okay, so if you not have solution, so you're gonna say not intersect. So it's gonna be the first equation, second equation, and the third equation. Okay, so you see that the way to solve is gonna be you just use 2 and 3 together, and you can just eliminate the variable s. So here you have 2 plus 3 given by 1, okay, equal to 5 plus 4t. So this one will be negative 4 equal to 4t. So you get t equal to negative 1. Okay, so you have t equal to negative 1. And you're gonna plug back into any equation in order to solve for s. Let's put this one in the third equation. So you have negative 3s minus 2 minus 3s equal to minus 1. So you get 3 equal to 3s, and you have s equal to 1. Okay, so you have s equal to 1, t equal to negative 1. Okay, so this one will be use the second and the third equation simultaneously. So we're gonna put these two guys, okay, so we're gonna put s and t that you have here in the first equation. So you put this guy in the first equation, so you get 2 plus 1 equal to 4 plus negative 1 to see whether that is also satisfy 1. So you would get 3 equal to 3, okay? So it means that you have s equal to 1, t equal to negative 1 that will satisfy these three equations simultaneously. Okay, so it's true. Okay, so you would get s and t that you're looking for. So in order to have, okay, so you're gonna have s equal to 1, okay? So you have x equal to 2 plus 1, y equal to negative 1 plus 3, and z equal to 2 minus 3. So in this case, you're gonna have x equal to 3, y equal to 2, and z equal to negative 1, okay? So the intersection point is 3, 2, and negative 1. Okay, so it's gonna be the intersection point. Okay, so if it turns out that you not be able to find the intersection point, it will mean that it's gonna turn out to be not intersect. Okay. Okay, so I will give you one more example. We like to show that the line x minus 1 over 2, 2 minus y, z, and L2 are skewed line. So when you like to show the line skewed line, it means not parallel, not intersect. Okay. So the way that we're gonna show not parallel, we're gonna use the vector v1 and v2. Okay, so you see that v1 is not a multiple of v2. So you have L1 and L2 are not parallel. Okay, so you have V1 not a multiple of V2 because if you see that V1 is one direction and V2 is another direction, so in this case it's not parallel for sure. So we gonna say that the line L1 and L2 will point in a different direction. So it's gonna be like this. Okay, so you see that it's gonna be pointing to different directions. So it's not gonna be parallel like this. Okay, so it's gonna be something like this instead. Okay. However, the way to show next is gonna be we're gonna try to show that they not intersect. When you like to show that this guy are not intersect, you're gonna try to solve for x, y, and z simultaneously. Okay, so the next thing is gonna be we try to solve for x, y, z. Okay, that satisfy L1 and L2. Okay, simultaneously. Okay, so we try to solve for x, y, and z that satisfy L1 and L2 simultaneously. The thing that you can see will be we're gonna solve for y and z first. Should be simple. Okay, so let's just look at the thing that I will highlight here. So you see that this one first equation and the second equation. So you see from these two equations that you're gonna be able to have 2 minus y equal to z and y equal to z minus 2. Okay, so this one is your first and your second equation. And you see that you have 1 plus 2 give you 2 equal to 2z minus 2, okay, and you're gonna have z equal to 2, okay, so you have z equal to 2, so you get y equal to 0. Let's take a look. So you see that you have equation 1, 2 minus y equal to z, equation 2, y minus y equal to z minus 2 taken from these two relation, okay? So you see that it's gonna be this guy, and you solve for z, it's gonna be z equal to 2, and you have z equal to 2, you would get y equal to 0, okay? So we're gonna put y equal to 0, z equal to 2 in L1 and L2 to solve for x, okay? So we're gonna see whether the x that you put y equal to 0, z equal to 2 in L1 and L2 agree or not, okay? You must have the same value of x, okay? So you must have the same value of x. So in L1, you put in L1, you have y equal to 0, y equal to 0. So you get x minus 1 over 2 equal to 2. So you have x equal to 5. Okay, so you have x equal to 5. So in L2, you have y equal to 0. Okay, so you get 2x minus 1 over 3 equal to 0. So you would get x equal to 1/2. Okay, so it's turned out to be not agree. Okay, so you see these two numbers not agree. Okay, so they not agree for the same value of x. So in this case, we're gonna conclude that these two lines are not intersect. Okay, so these two lines are not intersect. They are not intersect. Okay, I need space. Okay, so you're gonna conclude that L1 and L2 do not intersect. Okay, so that will be, so they are skew line. Okay, so that's all you need. Okay, so that would be all for this lecture. Okay, so that is gonna cover everything that you need to know about the lie, and I would gonna give you one example that I'm gonna let you do this one first, and then I'm gonna give you the solution at the recitation. Okay, let me. Okay, so I will give you one more example that I will allow you to do this one on your own first, and we're gonna get the solution during the recitation. Okay, so I give you one more example. Show that. Okay, and one given by x equal to t, y equal to 1 plus 2t, and z equal to 2 plus 3t, and L2 x minus 3 over -4 equal to y minus 2 over -3 equal to z minus 1 over 2. Okay, skew line. Okay, so we like to show that L1 given by x equal to t, y equal to 1 plus 2t, and z equal to 3t, and L2 is x minus 3 over -4, y minus 2 over -3, and z minus 1 over 2 are skewed line. So you need to show whether they not intersect and not parallel. Okay. Okay, so please do this one on your own first, and then I will give you the solution during the recitation next time. Okay, so that's all for the lecture on the line.